The topic is interrupt classification in 8086 microprocessor. In 8086 microprocessor, interrupt can be classified in two categories. That is the hardware interrupts, and second one is the software interrupt. In 8086 microprocessor, there are two hardware pins related to the hardware interrupts. That is the NMI, non-maskable interrupt, and INTR. Okay. Non-maskable interrupt NMI is having higher priority than the INTR interrupt request pin. So NMI does not depend on the interrupt enable flip-flop set or reset status because it is non-maskable and you cannot avoid it. So microprocessor definitely have to service any interrupt request onto this pin. Okay, but you can disable this pin by setting 0 into this pin. Means you are not accepting any of the interrupt right now. Okay, so you can disable NMI pin by setting 0 to this hardware pin in 8086 microprocessor. But if it is connected to 1 and any of the peripheral devices send any of the request, you cannot ignore it. You have to service it by ISR programs, that is interrupt service routine programs. Okay. And second pin INTR is having lower priority compared to the NMI pin. So INTR is the maskable interrupt pin which can be set or which can be enabled or disabled, means masked or unmasked by using the interrupt enable flip-flop register. Okay, so there is one instruction, set interrupt flag register in 8086 microprocessor. Similarly, the EI and DI instructions in 8085 microprocessor. Any interrupt request acknowledged by the microprocessor at the pin INTA for NMI hardware pin. So if microprocessor executing some program, it will complete the execution of the instruction which was in progress and pushes the flag register value onto the stack. Okay. NMI hardware interrupt can be serviced by pushing the flag register value into the stack and also pushing the code segment and IP value into the stack. Okay, so similarly, like in 8085 microprocessor, program counter contains the address of the next instruction. Here in 8086 microprocessor, code segment and IP contains the address of the next instruction, where code segment is the part of the segment memory and IP is the instruction pointer which contains the offset address of the code segment memory. If the interrupt is serviced, the return address again will store into the code segment and IP, and the main program will be executed similarly the microprocessor was doing previously. Okay, so the second interrupt is INTR, interrupt request, which is having lower priority compared to the NMI interrupt and is dependent on the interrupt enable flip-flop. The instruction used in the 8086 microprocessor related to the INTR interrupt is set interrupt flag. So if you set this interrupt flag status to 1, the INTR is unmasked. If you reset it, the INTR interrupt pin is masked. Okay, so you cannot accept any interrupt request onto this pin. The second broad category is the software interrupts. In 8086 microprocessor, total software interrupts available are 256, which are called from type 0, type 1, type 2 to type 255. Okay, so software interrupts are basically type 0, type 1 to type 255.